want the answer for this tomorrow as well. I'm going to make this up. Okay. First one is this. Half a meter diameter pile, 10 meters getting rock socketed. It got some load on the top. So work out the buckling load. Okay. So you need obviously to work out what the E of concrete is, I of concrete is, and so on. Yeah. And then see. The next one I want is same soil, same piles, but this time you got so what you want to work out is for the pile group and the single pile, what is the peak rate per pile, and explain why if they're different and why. Okay? Work those out and show it to me tomorrow. Otherwise, I won't be pleased. Rock socketed, as shown. Okay, we'll stop there. Okay, sir? So, afternoon.
Start 2 o'clock.
2 o'clock. Maybe today we will focus on what you learned so far and see what calculations we can do. And tomorrow and Friday, you're going to try and use the FLAC, right? Sorry, Plaxis, right? So we need to set up a problem that you can analyze that. Huh?
We will also explain
Abacus. Yeah, but for seismic problems, Plaxis works, right? So you probably want the Plaxis. You need to think about that.
better to concentrate on the plan.
Huh?
Better to concentrate on planning.
Plaxis, yeah, that's the. But I don't know whether they have the dynamic bit and the Manzari model in it. Because it depends what components they purchased with Plaxis.
Actually, sir, our practice license that is expired. What is the problem? You mentioned like to come. Yes.
Okay, so in that case, we can do like a Abacus is a 3D.
Yeah.
So if you can create the pile and the soil in it, and by changing the head load, it will change the inertial load being applied, and we want to get the bending moments in the pile for different load application. Okay, so that would give them an indication of inertial loading coming onto the pile. Right.
It is important because we are not having a venting license at the moment. So it is important that we not do it.
Oh, you mean for praxis? Yeah, yeah. They'll come after you. Okay, so but for this afternoon, what we thought you could do is uh, day before yesterday we gave you the Sudan webs data from the Sudan site, right? So that has different lithographic units. I think up to about 20 meters, 15 meters, and you have the CPT data, right? For this. So use the CPT data, and first thing I want you to do is to say if I have a pile going like this, yeah, so I'm going to apply 25 kilonewton load. That's like 2.5 tons on pile diameter of 300. So what we want to know is what's the pile capacity? Yeah, using the CPT data, how do you estimate it? And so what is QP and what is the uh, once you get this, you can work out the factor of safety, because this is the estimated capacity. We're applying 25 kilonewtons. You should know what is the margin of factor of safety. Yeah. Now, the other thing is you also estimated for this problem that this soil will liquefy and settle, right? So what will happen then? So post earthquake, so this is all static or pre-earthquake, right? But post earthquake, maybe up to data you got how much? About 300 millimeters of the soil layer. The soil layer, right? So the soil itself is going to settle, but the pile is going to stand proud. So if that happens, what extra load will come onto the pile? The soil wants to settle, pile doesn't want to settle. So what is the new factor of safety? Do you understand the problem? A row settlement of the pile. Yeah. So if you calculate the settlement of the pile, if that is less than 300 millimeters, that's when negative skin friction will come. If it is more than that, obviously it is settling more than the soil, therefore you will get positive skin friction. Yeah? You will get positive skin friction. Yeah? So that's the calculation. calculation. So if all of you have done the first set of calculations like I have asked, we are building on that, right? Because that is just for the soil. Now you are doing it for the pile inside the same soil. So it's important that you do the homework that is sent. But anyhow, this you're going to sit down and everybody has piece of pen, paper, calculator, that kind of thing. Yeah, get on with it then. If you're not sure, I'm here. Professor Agnihotri is here. Come and ask us. Yeah, you are doing it like a static account. You are adding the new system. This is what we add. If you get this number, cases are there. Right? Two. Okay. And when you apply the down drag, you can use the same QC values. But because the soil is now cooling it down, use drag instead of adding it, then your factors will come down. Spoil around it, then the factor of safety should come down. Because the down drag is adding as an extra load on the shaft, you lost the shaft capacity, therefore your factor of safety should come down quite significantly. And some of you showed the numbers of close to 1, which means the piloter is for failure. Okay? So it's what should have happened. Anyway, do finish the calculations. Also, do the buckling calculation for tomorrow. We'll take it, we'll start again tomorrow. Is it 9:30 or 10?
Schedule is 9:30, but now they are going to 10.
Depends on the day. Yes. Okay. Yeah, 10 is good.
Okay? See you tomorrow.